For ages, a diamond was this mythical thing, something you had to pull out of the ground. But what happens when we figure out how to cook them up in a lab? Well, today we are diving deep into the brilliant, high-pressure story of synthetic diamonds and the incredible cat-and-mouse game of trying to tell them apart.
You know, this one single question has been the obsession for scientists and engineers for decades. And the goal wasn't to make a fake diamond, not at all. It was about recreating nature's most dazzling, most perfect masterpiece, completely from scratch.
Okay, so right off the bat, let's be crystal clear about something. When we say synthetic, we are talking about a real diamond. It's got the same carbon atoms, the exact same crystal structure, the same incredible sparkle. The only thing that's different? Its origin story. One came from a lab, the other from deep inside the earth.
So, how did this wild dream even become a reality? Well, the journey really gets going in the back half of the 20th century, and it was a few key breakthroughs that just changed everything.
It really kicked off in the 70s when General Electric managed to create the first stones that were actually good enough for jewelry. Then, by the 80s, you had Sumitomo over in Japan starting to produce them on a much larger scale. And then, get this, De Beers, the biggest name in natural diamonds, shows off this massive 11-carat synthetic crystal, basically showing the world just how far the tech had come. By the 90s, Russian scientists were in the game with their own unique methods. The race was officially on.
So that first big success story, it came from trying to copy Mother Nature's own recipe. You know, just a little bit of immense pressure and some absolutely scorching heat. And that method is called HPHT, which stands for high pressure/high temperature. And honestly, the best way to think about it really is as a high-tech pressure cooker. You just take the right ingredients, you squeeze them unbelievably hard, and you bake them until something brand new and brilliant forms.
The process itself is just wild. It all starts with a teeny tiny diamond seed. Then you add your carbon source, like graphite, and a molten metal mixture that acts as a catalyst. Then comes the main event. You apply this crushing pressure and intense heat, and over days, maybe even weeks, those carbon atoms slowly migrate through the metal and crystallize right onto that seed, growing a brand new, bigger diamond.
But, and this is a big but, in the early days, this whole thing was incredibly expensive and so slow. I mean, check out this editorial from 1986. The thinking back then was that, sure, these lab diamonds were cool science experiments, but they were way too costly to ever really compete with natural gems. A single crystal could cost something like $20,000 just to grow. But as the technology got better and cheaper, a whole new question popped up. If they're real diamonds, how on earth are we supposed to tell them apart? And this kicked off the other side of the race, the science of identification. Luckily, that whole high-tech pressure cooker process, well, it left behind some pretty obvious clues. Gemologists quickly learned to look for things like tiny metallic bits trapped inside, or weirdly geometric color patterns, and unique graining. But honestly, two of the most fascinating clues are how they glow and their magnetic personality. Yeah, you heard that right. This is one of the weirdest tells, because these diamonds are grown in this kind of iron-nickel-metal soup. Tiny microscopic bits of that metal get trapped inside the finished diamond. And the result? A lot of HPHT synthetic diamonds are actually attracted to a strong magnet. A natural diamond would never, ever do that. The other dead giveaway is their fluorescence. You see, when you put an HPHT diamond under a UV lamp, it doesn't just glow, it often glows in these really sharp geometric patterns. You might see a perfect cross shape or a square, which maps out exactly how the crystal grew, piece by piece inside the machine. It's like an unnatural fingerprint. So just as gemologists were getting really good at spotting these HPT diamonds, a totally new technology came along, and this one didn't use a pressure cooker at all. This new kit on the block is called CVD, or Chemical Vapor Deposition. Now, instead of all that crazy pressure, it uses a vacuum chamber. And instead of a metal soup, it uses a carbon-rich gas, like methane. So if HPHT is a pressure cooker, CVD is much more like 3D printing, literally building the diamond atom by atom, layer by painstaking layer. And right away, this brings up a huge question. Does this totally different method leave behind the same clues for gemologists to find? The answer was a big, fat no, and that sent some serious shockwaves through the entire industry. So that brings us to today, to the modern era. It's become this high-tech showdown where these incredibly advanced synthesis methods are being met with equally advanced detection technology. You see, the problem with CVD diamonds is that they're almost too clean. There's no metal soup, so there are no magnetic bits inside. And their layer-by-layer growth means all those old geometric color patterns were just gone. All of a sudden, a standard gemologist microscope just wasn't going to cut it. The industry needed brand new tools.
And that's when the new wave of tech came in. The first line of defense became these screening devices, like the diamond sure. It works by looking for a very specific feature in how the diamond absorbs light, a feature that's in almost every single natural diamond. If the machine sees it, boom, it gets a pass. But if it doesn't see it, it flags the stone and says, hey, refer this one for a closer look.
So for all those referred stones, the next stop is a beast of a machine like the Diamond View. This thing basically bombards the diamond with super high-energy UV light, which makes its hidden internal growth structure light up, revealing the truth. The HPHT diamonds show their classic geometric patterns, while the CVD diamonds show these distinct parallel layers, almost like the rings of a tree, that totally give away their 3D printed origin.
So let's just put it all together here. This table really is a fantastic summary of the whole thing. Natural diamonds have natural inclusions and growth patterns. HPT synthetics, they're defined by those metallic inclusions and their geometric zoning. And the CVD synthetics are all about that layered structure and having no magnetic personality whatsoever. Each origin story leaves its own unique telltale fingerprint.
So really, the crucial point here, the big takeaway, is that this whole story has been a kind of technological arms race. For every single leap forward in creating diamonds in a lab, there's been an equal leap forward in figuring out how to detect them. The cat has always managed to keep up with the mouse.
But it does leave us with one final, kind of mind-bending question. As our ability to perfectly replicate nature gets better and better, are we eventually going to reach a point where the difference between a diamond from the earth and a diamond from a lab becomes not just invisible, but completely meaningless? Now that's something to think about.